Hello everyone, welcome back to our channel. In today's video, we will be discussing about interval and set builder notation in finding for the domain and range. So, let's get started. Okay, so we will be discussing about interval and set builder notation. So I hope that you are going to listen carefully with our discussions regarding interval and set builder notation. This is in connection with our discussion about the domain and the range of a function, on how are we going to express or represent the domain and range in a particular function. So we have here interval and set builder notation. An inequality may have infinitely many solutions. The set of all solutions can be expressed using set builder notation or interval notation. These notations are presented below. So let's have an example. Okay, so we have here three columns. The first column is the column for the interval. This is how we are going to write the interval. Then this will be the set builder, and this is the corresponding graph. Now, if we have the graph, considering that we have a number line or a set of x values, so our a and b represents a specific integer on that number line. As you can see, on top of a and b is a hollow circle. A hollow, or it's an open circle. It means to say that the integer a and b are not included in the solution set. Okay, so in interval, if we're going to represent this or express this one in an interval way of presenting it, we will have this one. We are going to use the parenthesis symbol. You have the open parenthesis a, comma, b. It means to say that the set of solutions is between a and b, meaning a and b are excluded. So in set builder notation, we are going to express this one. This is the equivalent expression. Since we have here, by the way, this is open and closed parentheses, meaning using the parentheses, it means to say that a and b are not included, and it is the solution set between a and b. So in set builder notation, we're going to express it in this one. Since we have here braces, okay, if you have braces, it is expressed, or this is read as the set of all x's such that x is greater than a and less than b. Okay. Again, this is the set of all x's such that x is greater than a and less than b. Now, let us proceed to another graph. Now, if we have a graph like this one, okay, so on the first graph, the circle is hollow on top of a and b. Now, on the second graph, we have solid circles. It's no longer hollow. It means to say that if we are going to express this graph into interval notation, we are going to use the square bracket. Okay, it means if we're going to use the square bracket, the open square bracket, meaning to say a is included and b here also is included, meaning the solution set of this graph is from A to B and all the points in between. For set builder notation, this is expressed as the set of all x's such that x is greater than or equal to A and less than or equal to B. Okay, you have noticed that there is an equal to symbol. From x is greater than or equal to A, it's because A here is already included in the set. B is also included in the set. So you might be asking, why is it we keep writing A first before B? Because we have here A is, we're going to arrange the set least to greatest. So this is the least one. If we're going to think of a number line, the left side is always the least value compared to the right side. Okay, let's proceed. Okay, how about this presentation, this graph? Now, if we have this graph, we have here A with a solid circle on top of it, while B is a hollow circle, or we call it open circle. Then the interval would be, and always remember there's also an arrowhead. There's also an arrowhead here, both sides. So we're thinking of a number line again. So if we have here, in this graph, this is expressed with the interval A, B, wherein A, before A we have the open square bracket A, then B, close parenthesis. Again, why is it that we use the open square bracket for A? It's because A is included. On top of it, the point is included. It's a solid circle. While B is an open circle, meaning it's excluded, meaning not part of the solution set. When it is expressed in set builder notation, we have here, it is the set of all x's such that x is greater than or equal to A and less than B. Okay, there is equal, less than or equal to A because A is included. There's no equal symbol in B because B is not part of the solution set. Okay, I hope you understand the concept. Now let us proceed to the next graph. This one, it's the other way around. A here has an open circle on top of it, and we have B which has a solid circle. So in that case, we have here an open parenthesis A, comma B. We have the close square bracket. We call it square bracket. So why is it A? Why is it that we write the close parenthesis before A? It's because it's hollow. It's not included. Okay? Then B, we have the square bracket because it is included in the solution set. And in set builder notation, we're going to express that one as, always remember, you have to write the braces. The set of all x's such that, okay, such that x is greater than A and less than or greater than, less than or equal to B. Again, the set of all x's such that x is greater than A and less than or equal to B. Okay. Let's proceed to the next graph. Okay. How about this one? Now, as you can see, there's no B anymore. There's no integer B anymore. We're dealing with one integer. We have only A, but it has an open circle. So how are we going to write or express the set of solutions or the solution set with this graph? Again, we're just using the x variable here. Okay, but we can also use y or any other variable. So in this case, we have here, since A is excluded, since it has a hollow circle, or we call it open circle, we are going to use the open parenthesis, then write A. Then, since the arrows goes on forever, going to the right direction, meaning it goes infinitely, which means we will write here positive infinity. Then we have to use the parentheses. By the way, we don't need to use the square bracket if we have to write infinity. If we will use the symbol infinity, we are going to use the parentheses. Okay. So for set builder notation, this is expressed as set of all x's such that x is greater than a. Okay, greater than a. If this is a solid circle, this must have an equal symbol. But since it's a hollow circle or open circle, meaning we only have set of all x's such that x is greater than a. Okay, let's proceed to the next example. Okay, if we have a graph like this one, it's already a solid circle, then the arrowhead is going to the right direction. So since it is a solid circle, we will be using the open square bracket, then comma, positive, infinity, the symbol for the infinity. Then we will use the parentheses as always if we have infinity symbol. Then for the set builder notation, we will have the set of all x's such that x is greater than or equal to a. So I hope everything is clear so far. Let us proceed. Let's continue. Okay. So what about if it's like this one? Okay. If we have this graph, we don't have a here anymore, but we have b. So on top of b is a hollow circle or open circle. So meaning on the right and the left side here, we have, remember in a number line, we have this negative, 0, then positive integers. Okay, so meaning if it goes on to that direction, meaning it will goes to the negative infinity. So we have here the close parentheses, negative infinity, then you have b until b, then close parentheses. We use close parentheses because it is an open circle or hollow circle. And for set builder notation, this is expressed as x, or the set of all x's such that x is less than b. Okay. Then let us proceed to the next graph. How about if the graph is like this? The difference between the first and the second one is that the integer b is a solid dot or a solid circle. If it is like this, you are going to write the interval. You have the close parentheses, negative infinity, comma, then you're going to write the integer b, and you will use the square bracket. It means to say that the set of all x's between, or not between, until negative infinity until b, meaning the integer b is included. So for set builder notation, we have here the set of all x's such that x is less than or equal to b. They are just the same, or the meaning is just the same. Next, how about this one? You cannot see the integers a and b, but again, we're talking about the x values. So this graph can be presented as this is graph as presented as the open and close parentheses. We have the negative infinity, comma, positive infinity. So we have here the set of all x's such that x is an element of real numbers. Again, the set of all x's such that x is an element of real numbers. Okay. So always remember that real numbers, that includes rational and irrational numbers. So this is the symbol for real number, and this is the symbol for element. Element meaning, again, the set of all x's such that x is an element of real numbers. Okay, now let's proceed to examples in which we can find the domain and range represented, or we are going to express it in an interval or set builder notation. So we have here this example. Okay, so if we have this example, this is the graph, and we have this Cartesian plane. This is our graph, and we are asked to find the domain and the range. So we can express this one. If this is our graph, how are we going to express our domain? In an interval. Okay, so for the interval, our domain would be, our domain would be is equal to, we have the parentheses, the negative infinity to positive infinity. And we will use the parentheses as always, okay? Because the graph has arrowheads in both directions. So it will goes on to that direction as well as this one. So meaning our x values, the domain, since we are talking about the domain, so we will be talking about here in this side. So this is, since this is the graph, the line graph, it will goes on to that direction and so forever or infinitely. So you have negative infinity and also here positive infinity. So that is for the interval. Okay, so we have here, okay, this is for the interval. Okay, so our range, how about our range? How are we going to write our range? Using the interval. So we have for the range using the interval, we have here negative infinity. This is our y values. Remember, y values, we are going to look at the graph and then the vertical, we're going to look at the vertical portion. So we have here, since the graph goes on that direction, both directions infinitely, therefore our range would be negative infinity to positive infinity. Okay, this is for the interval. This is how we're going to present this using interval for the domain and the range. Now how about for the using the set builder notation? Okay, this is just this same as set builder notation, but we could also use symbols. This one, you have your any real numbers r, or can be written as x is an element of r. For the set builder notation, we will just going to add. Okay, this is all right, but it is also to make it complete, we can have this one. We will write x. So the braces will be here. The braces will be here. That the set of all x's such that, okay, such that x is an element of real number. So this is for the set builder. Okay, this one will be for the set builder. And for the range, you have here any real numbers are, or can be written as the set of all y's an element is an element of real numbers. Since here we're dealing with domain, so the variable is x, but here for the range our variable will be y. So you will have the braces is here, then you will write y, then we will use the slash, meaning the set of all y's such that y is an element of real numbers. Okay, I hope everything is clear so far. Now let's proceed to the next example. Okay, for the next example we have here, this is our graph. This is our graph. As you've noticed, the graph has solid circles both ends. So to find for the domain, we need to do like this one. This is our domain. So these are the set of our domains on the graph. Okay, from 2 to 4. And since we have here we have here the solid circles from 2 to 4, meaning 2 and 4 are included. If 2 and 4 are included, so we have here to find the domain and range using the interval. This is how we are going to write. Okay, so we have here for the domain using the interval, that would be, since they are included, what we're going to do, remember we're going to write the lesser value on the left side. So we'll use the square bracket because 2 is included. So you will write 2, then comma 4. You have here 4 and 4 is also included. So you will write 4, then we have the square bracket. Okay, that's for the domain. And for the range, we have, for the range, you can have, okay, for the range, we're going to look at this one. This is our range. The y values, the set of y values are range. So we will be looking at the vertical one. So from 6 to 10. And from 6 to 10, since it has, or the graph has a solid circles both ends, meaning they're also included in the set, aside from the real numbers in between. So we'll have this one. So our range is the set of all numbers from, or in which 6 is included. So there's 6, then you have comma, then 10. You have 10. Okay, so this is now our interval. This is how we're going to express the graph using interval for our domain and range. Now how about for the set builder notation? Okay, or inequality. So for the set builder notation, we have here this one. The domain would be, so you will just add here. Again, for the domain, we will use the value x. That's for the set of x values, and for the range, we'll use the y values. So we will just add a braces here, then x, set of all x's such that x is greater than or equal to 2 and less than or equal to 4. Okay, so this tells us that 2 and 4 are included in the set. Now let us proceed to the range. Now for the range, we have the set of all y's such that, okay, the set of all y's such that y is greater than or equal to 6 and less than or equal to 10. Okay, so this is how we're going to express our domain and range based on this graph. I hope that still everything is clear so far. Now let us proceed to the next. Okay, what about this graph? Okay, how we're going to express the domain and range using this graph? So if we have this one, we're going to look for the domain and the range. Again, the domain, you focus your attention on the x value. So we have it here from 3 to 5. Okay, this is our x-axis. So you have your 3 to 5. And as you've noticed, for 3, it has a solid circle, meaning it is included in the set. And for 5, it's an open circle or hollow circle. It means it's not included in the set of values. Okay, so we are going to write for our domain. Okay, let's start with the interval. Our domain would be this will be the interval. Since 3 is included, so we will use the square bracket, then comma, and 5 is not included, so we will use the close parentheses. Okay, that's our domain using the interval notation. Now for the range, how about for the range? For the range using the interval notation, you will have, okay, so focus your attention on the y-axis. So you have here, let's start from the bottom, then up. So we have here 10 and 26. So since 10 is included, we will use the square bracket. You write 10, comma, and 26 is not included, therefore, sorry. So we have here 26. Use the parentheses. Okay. So this will be our representation of the domain and range using the interval notation. Now how about using the we will use the set builder notation. For set builder notation, we will, to make it complete again, we will just have this one. Okay, we have the set of all x's such that, okay, such that x is greater than or equal to 3 but less than 5. Okay, for the range, we have here the set of all y's or all y's such that y is greater than or equal to 10 but less than 26, or we will use and less than 26. Okay, I hope everything is clear. And let us proceed to example number 5. Now consider this graph. Okay, if we have this graph, as you've noticed, there's a point on this graph here, a single point, and here we also have a point, a hollow circle, meaning this is not included. However, if we are going to express the interval notation for the set of domain, so under the set of domain, we're going to focus our attention on the x-axis. So our domain would be, we're gonna start here. We're gonna start here towards that side, because this is the graph has an arrow going to that direction. So even though we have here a hollow circle here, meaning it's not included, however, there is a separate point which tells us that -1 somehow is still included. So we will be using the square bracket. You have here the open square bracket. You have here -1. Then, for a moment, we have, okay, it should be, okay, for a moment, I'll use the eraser first. Okay, since it is to the negative infinity, this is how we're going to use. So our domain would be this one. Our domain would be negative, because we are going to write the set from left to right. So we will have the negative infinity, then comma, -1, then we will use the closed square bracket. Meaning to say, -1 is included in the set of domain towards the negative infinity. Okay, so we'll proceed to the next. For the range, now for the range here, we cannot express using the interval notation. Okay, why is it we cannot express for the interval notation? It's because we have y is equal to specifically -1. Positive 1 here. Y is equal to 1, just like this one. Then we also have this, that y is greater than 3, but we cannot express that using interval notation. We cannot use more than 2 symbols when expressing on the interval notation. So instead, if we cannot express this in the interval notation, so we will just write it this way. So we'll just use the set builder notation. For the domain, we have set of all x's, the set of all x's such that x is less than or equal to -1. Okay, we have here set of all x's such that x is less than or equal to -1. For the range, the set of all for the range, y is equal to 1, and the set of all y's such that y is greater than 3. So you are going to write first y is equal to 1, that's separate, and then such that y, set of all y such that y is greater than 3. Okay, so this will remain blank because we cannot express this one in interval notation. Let us proceed. How about this graph? So if we have this graph, this is from piecewise function graph. So if we have this graph, how we're going to write the interval notation for the set of domain? So let's start with the domain. So for the domain, we are going to focus on the x-axis. So here's the domain from here, this side to this one. So this is our reference point from 2 to 3. Okay, so is from 0 to 3, I mean. So what have you noticed with 0? Is 0 included in the domain? In our domain, 0 is included because this is a hollow, and this is a solid dot or solid circle. So we will be using the open square bracket. So you have 0. Then it ends up at 3. But 3 is excluded. It's not part of the solution set. Therefore, we're going to use the close parenthesis. Okay. Next, we'll continue. For the range, okay, so for the range here, we cannot use the interval for the range. The interval, we cannot use the interval notation in stating for the range, but we can use the set notation. Okay, set notation. It's like this one. Okay, let's go back to the domain. The domain would be the set of all x's, the set of all x's such that, okay, the set of all x's such that x is greater than or equal to 0 and less than 3. For the range, we only have specific. This is our range. These are our range. I mean, from here. Okay, so this is our range. However, However, only 2, 4, and 6 because the graph does not cross in between 2 to 4 and 4 to 6. So these are only specific integers. So we have arranged, this is what we call set notation, wherein we'll just simply write y is equal to 2, y is equal to 4, or y is equal to 6, or just simply, you can just simply write 2, for a moment, you can simply write 2, 4, 6. Okay, we will just use the set notation. Just simply list down the elements of the y set or y values. Okay, let us proceed to the next example. Now, what about if this one? So how we're going to present for our domain? Okay, let us start with our domain using the interval. Our domain using the interval. So you will have, again, we're going to focus on the x-axis. We're talking about the x values. So from here to that direction, because we have here an arrowhead. So this is our reference point. However, for 4, it has a hollow circle or open circle, which means it's not included in the set of domain. So if it is not included, we will use the parentheses. So we have here 4, then comma, until the positive infinity. Okay, that's our interval. And if we have infinity, we always use parentheses. That's for our domain. Now, how about our range? Okay, now for our range, we have the value of our range. So we have, this is our focus now. That's from 2 to 4. So the range would be from 2 to 4, and 2 is hollow, meaning it's not included. So you will write 2 with in open parentheses, meaning it's not part, then until 4, and 4 is included in the set, so we'll use the closed square bracket. Okay, so I hope that you were able to follow how to write or express the graph in interval notation as well as in a set builder notation. And in case you cannot express it in a interval notation or set builder notation, we will just simply use the set notation, wherein you're just going to mention or list down the values, specific values of y or x, or your domain and range. So here, let us proceed to the set builder notation. So for the domain, we have the set of all x's such that x is greater than 4. Okay, this is how we're going to write to make it complete. Then for the range, we have the set of all y's such that, okay, the set of all y such that y is greater than 2 but less than or equal to 4. Okay, so we have, I think we have enough examples already. So this time we will have an assessment. Okay, so we have here, for each graph, give the domain and range in an interval notation and set builder notation. Okay, you will use the set builder notation. So this would be the set builder notation. Although it is also sometimes it is also expressed in an inequality notation, but to make it complete, you just use the set builder notation. Set builder. Okay. So you are given the graphs. Please do copy this on your math activity notebook. So you have number 1. This is your graph. Write the interval notation, the domain, and the range. By the way, again, for the instead of inequality notation, you just write set builder notation. And if you cannot express the domain and range in set builder notation or interval notation, you will just simply use the set notation, wherein you're just going to mention the specific values of your range or domain. So this is our number 1. This is the graph. This is number 2. This is solid circle. This is open circle. Number 3. These are solid circles. Then number 4, we have this one. This is the graph with arrowheads both ends. Number 5, we have a circle. Number 6, we have the dots. These are the dots. 1, 2, 3, 4, 5. 5 dots. Then for number 7, we have this. By the way, you don't need to answer what type of function is this, as well as this one. What type of function is this? Okay, just simply answer, express the interval notation, domain and range, and as well as the set builder notation. But for this one, you can answer this one, letter C and D. Okay, so this one also, we have an example of this already. Okay, and this is our number 9. You have to write, you don't need to answer letter A here, as well as A in number 7. Okay, so let's proceed. For number 10, you have this. Number 11, you have a triangular shape. This one is ellipse. Number 12 is the graph. This is a solid dot, and this is an open circle or a hollow circle. Okay, so I hope that everything is clear, and I hope that you're going to enjoy answering 12 items in identifying the domain and range using the interval notation and the set builder notation. Okay, and to end this video, let's have a quote. Wherever there is a number, there is beauty, by Proclus. So thank you so much for watching, and don't forget to subscribe to the channel. Bye.